The pros and the critics all agree that this one simple thing can change your life. Okay, so I really wouldn't go that far, but I think a lot of people can agree that a nice quality of life upgrade for their 3D printers is to add some kind of contact sensor to their machines by way of the CRTouch or the Biqu Microprobe, or in my case, I've got the Antlab's BLTouch mounted on my Neptune 2 and my Neptune 3. I've got a CRTouch on the Creality Ender 3 V3 SE that was pre-installed, and I've got an inductive sensor on my Artillery Sidewinder X3 Plus. Now, some of you playing along at home may remember that a long, long time ago in a galaxy far, far away, I did a comparison video that compared and contrasted the original Neptune 3's strain gauge, where it uses the nozzle for the bed leveling, and then I compared that to an inductive sensor, a capacitive sensor, and a BLTouch. Obviously, I opted to stick with the BLTouch because I like a contact style probe, and the BLTouch was, I forget what it was, probably 10 times more accurate than the strain gauge. But the inductive sensor and the capacitive sensor were both accurate and repeatable in their own right. I just prefer the contact of the BLTouch, so I stuck with that. But when Elegoo introduced the Neptune 3 Pro, they decided to forego the strain gauge that they were having. Admittedly, it was pretty problematic. But they decided to get away from the contact sensor and go with an inductive style probe. But by doing so, they eliminated the BLTouch pins that were on the latest version of the board. In that case, it was the ZMP Robin Nano V2.2. The Neptune 3 original has a V2.1. And unfortunately, with that all being said, there's no way to add BLTouch functionality to a Neptune 3 Pro. But that doesn't mean that there's not a way around it. So eventually, like a lot of people do, I decided to try Klipper firmware on all of my machines, and I've been running Klipper firmware ever since. I have it on the Neptune 2, the Neptune 3, and the Ender 3 V3 SE. I don't have it on the Artillery Sidewinder yet because Artillery will not give up the goods. I keep asking them for their Marlin firmware, and they just won't let me have it. But anyway, when I was researching into Klipper, the one thing that stuck out to me was the fact that you could run multiple MCUs on a single printer. So not only do you have the I/O capability of the main board that's on the printer itself, but you could also connect third-party peripheral devices. You could connect another type of microcontroller board. So eventually, I picked up a Raspberry Pi Pico. And the Raspberry Pi Pico is cool because it gives you a lot of functionality that a Raspberry Pi would via the GPIOs that they have on here. It's not a full Linux system, but think of this more like an Arduino, where it's a microcontroller that you put a program into, and then you can use the I/O pins for inputs and outputs of various peripherals and what have you. So you could run relays off of this, you could run an ADXL off of this, you could actually hook this up and use it as a USB accelerometer. And in my case, I figured out how to make this run with a BLTouch. So I can hook up this Raspberry Pi Pico to any printer that does not have a BLTouch section on its main board, hook that printer up to Klipper, and install a BLTouch right from here. And that's the whole purpose of this video. I'm going to show you how to hook up a BLTouch to a Raspberry Pi Pico and connect to a Klipper instance so that you can use an external device to drive the BLTouch. So now you're not limited to the inductive sensor on any type of machine that came standard with an inductive sensor. So stick around and let's all learn something together. But before I do that, I'd just like to give a quick shout out to the sponsor of this video, PCBWay, who offer a multitude of PCB-related products and services such as PCB prototyping, PCB assembly, SMD stencils, as well as CNC machining and 3D printing services. Check out their website at www.pcbway.com. So the first thing we're going to have to do is go into the make menu config of our master Klipper device, the one that is running Klipper currently on the printer. In my case, it's the Bigtree TechPad 7. And start an SSH session by typing in SSH, the username for the device and then either the IP address or the host name for the device. Hit enter, put in the password, and then we'll go into cd:/Klipper. We'll run a make clean, clear out any files we don't need. and then we'll go into Make Menu Config. From here, we just make sure that our Make Menu Config is set up like we see here. We're going to use the microcontroller architecture is Raspberry Pi RP2040. The bootloader offset will be no bootloader, and the communication interface will be USB. So we can see right here, I've got all of that set up. I'll just hit Q for quit. And now what we're going to want to do is we're going to want to take the Raspberry Pi Pico, hold in the boot cell button, and plug in the USB to the device. Once it's plugged in, we can remove our finger from the boot cell button and then run this command, make flash _device equals first. You can simply click on this icon over here to copy it, go back to your SSH session and right click on it to paste. Hit enter and it will either flash the device or it will come up with an error saying that it can't flash the device. If it comes up and says that it cannot flash the device, then you would run this command right here. So it's the exact same thing, but the flash device equals 2E8A:0003. And you can see right here, it'll tell you exactly what you need to command if it doesn't work when you're using the equals first. After that, you don't have to unplug anything. The Pi will reboot itself. And then you can test the device by typing in ls/dev/serial/by-id/star. Just like you would to find the by ID for the main MCU for your printer. And then to configure it on your printer, go into your printer.cfg. I've got mine down towards the bottom. And what you have to do is you have to add a secondary MCU, so you can put in square bracket MCU and then just give it a name. It doesn't matter what the name is. In my case, I put RPI_Pico, but you could just put RPI, you could put asshat, whatever you want to put. Underneath that, the serial device is going to be the by ID that you got from the ls/dev/serial/by ID. You would just copy that and paste it right here. When you're setting up your BLTouch, you make a BLTouch section. Then you have your sensor pin and your control pin. These are the two that matter most. And your sensor pins, in the case of the Pico, are going to be the GPIO pins that you have your end stop and your servo control pins plugged into. In my case, I was using RPI_Pico GPIO 0 for the sensor and RPI_Pico GPIO 27 for the control. If I were to remove the pins that I have here, just put them at the end so I could revert back, here's what it would look like for the Pico. On the sensor pin, you have to use a pull-up. So you would just put this little arrow pointing up symbol, which is, on my keyboard, it's the number 6 if I hold in the shift key. And as long as the Pico is being seen by the system, everything should come up no problem. Well, I kind of wish I had a setup like this when I did those inventor videos. So when you get your Raspberry Pi Pico, it doesn't come with any header pins installed on it, but it does come with header pins that you can install. So I soldered the header pins on so I could plug this into a breadboard, and then I can set the Pico into the breadboard, and then I can test it out with different things. I wasn't buying this with the sole intention of putting it onto a single printer and then just leaving it. But what you could do with this thing is you could print out a small housing for it, or you can make a little mount for it to utilize the 4 screws that it has for mounting it, and then make an adapter plate to put it inside of your electrical enclosure if you want to do something like that. So I've already flashed this with the Klipper firmware. And again, to do it, you just hold in the boot cell button here, plug in the USB, release, and then do the make flash, and it'll put the Klipper system onto here, and then it's ready to go. As far as the pin configuration is concerned, I'll put a little graphic up in the corner, but as far as the pins are concerned, we've got 5-volt power that we need for the BLTouch. We've got ground that we're going to need in a couple of different spots. We need 5-volt and ground to power it, and then we need the signal and ground for the end stop. We also have the servo pin, and I've got this breadboard laid out and almost color configured for the color configuration of the BLTouch to kind of make it simple. So I've already flashed this with the Klipper firmware. And again, to do it, you just hold in the boot cell button here, plug in the USB, release, and then do the make flash, and it'll put the Klipper system onto here, and then it's ready to go. So to insert this onto the breadboard, we've got the one row and the other row of pins, and then there's a bridge in between these two sections here and here. So this section gets all of the I/O from this row of pins, and this section here gets all of the I/O from this row of pins. So as long as I line this up properly, just give it a little push to get it in place. Don't want to get too aggressive. It's not a huge board, but that's really it for my needs. And like I said, I've got it situated so that the white on this side goes to the white on the BLTouch. The blue wire goes to the black. And then on this connector, we've got red for power, brown for ground, and then this orangey yellow for the servo. So I've got this black wire here will plug into the brown for the ground. The red will go in the center for power. And then this orange wire will plug into the servo. Now I did find another website that had some documentation on how to set this all up. So I'll put a link for that in the description as well. But it was based on setting up a BLTouch on a Raspberry Pi proper, not on a Pico. But the instructions seemed to work out just fine for this use case as well. But it did point out that GPIO 0 and GPIO 1 have onboard pull-up resistors. So you want to make sure that your end stop goes into either GPIO 0 or GPIO 1. I don't know how much that holds water on the Pico, but I'm just sticking with what I discovered, and everything has worked out well, so I'm not going to try and reinvent the wheel here. But again, I've got power, ground, and the servo signal over here. And the servo signal is actually on GPIO 27. And the numbering convention does not go in a straight line on the Pico. So it'll be like GPIO 0 is over here, and then down here somewhere it's going to be like GPIO 6, even though you've skipped that many rows of pins. But just keep that in mind. Just read the diagrams and make sure that you have everything connected properly before you go and put power to this thing, and then you'll see magic smoke. Okay, so I've got everything set up in the printer.cfg. I've got the MCU section with the RPi Pico with the serial address for communication. I've got the BLTouch set up here on the Pico with the breadboard. I've got all of the GPIO pins set up, ready to go. So all I have to do at this point is just plug this in. You can see right here it already goes through the self-test. It is lit up in red. It means that everything seems to be happy at this point. I'll do a save and restart in Klipper. When it reinitializes, we'll see in third MCU right here, we've got the MCU RPi Pico, and everything seems to be on the up and up. So if I go into console, I can now do the BLTouch debug commands, and I can run through the pin down, the pin up, and what have you. I always forget what those commands are, so I'll go into the BLTouch section of the Klipper documentation, and I'm going to search for BLTouch debug command pin up and pin down. So I'll just copy that. I'll go into the console, I'll paste it, I'll do a pin down, and you can see that the pin comes down. If I do a pin up, you'll see that the pin now retracts. And at that point, so far the servo command is working, so that means that everything else should be okay, but then we could test out the end stop. And actually, if we just do a BLTouch underscore debug, it should tell us right up in here all of the different modes that we can run through for the debug commands. So that's pretty cool. We could even do a self-test, which makes the pin trigger in and out a handful of times. We've got the pin down and pin up that we've tried. We've got reset, a couple of different options that I haven't admittedly touched yet, but maybe one day. The one thing that we're going to want to do is make sure that we are in BLTouch debug touch mode. So I'll copy this command into the console, and then we can do a query underscore probe, and we can see right now it says triggered because it's in the up position. And if I do BLTouch command pin down and do the query probe, right now we can see it's in the open state. And if I call up query probe here and I just lightly touch it to where the BLTouch turns red. See, I errored it out. But even in the error state, we can see that it's in the up position and it says triggered. So I should be able to just do a pin down. Nope. So I'll go into the debug command and I'll try a reset. There we go. If we do the reset, it will reset the probe. I can do query probe. I'll do pin down. Query probe. It might not be in the touch mode still, so let's try it. All right, so it's touching. Oh, it errored out. So reset, pin down, touch mode, query probe, touch it, query, and we can see it says triggered. I'll just do a pin down again. You can see that it brings it down. So it is working. It's all set, ready to go, and it's running directly off this Raspberry Pi Pico. So I could essentially take what I've got here and just plug this into my Linux device, hardwire these onto a longer cable, mount this, and I'm ready to go. I've got a BLTouch. So I figured while I had you here, I didn't want to leave you hanging, so I went ahead and I connected an ADXL345 to the Raspberry Pi Pico, and I got it configured in the printer CFG. I'm actually using the GPIO pins 0 and 1 over here for part of the SPI bus. So I set up my ADXL section using the RPi_Pico GPIO 1 for the CS pin, and I'm using SPI bus SPI 0A. Disregard the CB1 stuff you see up here because that's commented out, and the MCU that we're running is still the RPi_Pico. I have the BLTouch now triggering on GPIO 15, and that does seem to be working well. So if I go into console and I go into BLTouch _debug command equals pin _ down just to make sure it's down. BLTouch debug command equals touch mode. I'll do a query probe. Right now it's open. I'll load that up. I'll touch here and we can see that it's triggered. Do a pin down again, do a pin up. And for the final test, we'll do an accelerometer _ query. And we can see that we're registering the feedback from the accelerometer. As far as the wiring is concerned, I pretty much just matched what wiring diagram they have in the Klipper documentation to the point where I'm even using the same color codes. So as long as you follow the wiring in the documentation, again using SPI 0A, everything should come into play. I'm using the 3.3 volt, but this is a 3 to 6 volt sensitive accelerometer. Careful if you don't get one. You may have some magic smoke if you hook up a 3.3 volt ADXL to the 5 volt pin. So keep that in mind. But I figured, hell, I had it all set up. Let's get them both going. So now we've got the ADXL 345 and the BLTouch running on a single Raspberry Pi Pico, which is fantastic for you Innovato Quadra guys, because now you've got the ability to set up an ADXL. And now if you have a Quadra running on your Elegoo Neptune 3 Pro, Plus, or Max machine, well, hell, now you got access to a BLTouch. So I'll go ahead and chalk that up as a winner. So my takeaways on setting up a Raspberry Pi Pico to run additional GPIO are that it is very easy to do, and it gives you additional functionality that some stock boards may not offer. In the case of the newer Elegoo Neptune printers, this means you can set up a BLTouch on a machine without a servo pin available on the stock MCU, and on a Linux device that doesn't have GPIO, you get the additional inputs and outputs needed to do things you could only normally do with a single board computer with a dedicated I/O section. It's great for anyone wanting physical touch bed measurement instead of an inductive sensor, but it also opens up build surface possibilities such as using a glass plate or a G10 surface instead of the stock PEI sheet. Keep in mind that as of right now, I only know of Klipper support for the Raspberry Pi Pico, although a quick trip to the Oogly Googly says that there is Marlin development being worked on as well. So that'll about wrap it up for this video. If you liked it, hit the thumbs up. If you enjoy the content and haven't done so yet, please subscribe. And if you know somebody who would enjoy this type of stuff, share it with a friend because sharing is caring. Check out my affiliate links in the description down below at no additional cost to you. It just puts a little bit of catnip into my kitty and it helps my future channel endeavors. If you're on that cesspool that is Facebook, join the group. Elegoo Neptune Series 3D printers, mods, tweaks, and improvements, where we offer 24-hour live chats and community support, do the occasional giveaway, and blatantly abuse the everyone tag. But hey, at least we're not a spam fest of 3D artists like those other pages. If you got 10 seconds to kill, check out my website at www.theferalengineer.com. It's just a whole bunch more of the same stuff, but it justifies the $12 a year I spend on the URL. And once again, thank you to all of my Catnip contributors, both past, present, and future. Thank you for watching, and we'll see you again soon. And I've got an inductive sensor on my artillery Sidewinder X3 Plus. And I've got an inductive sensor on my artillery And I've got an inductive sensor on my artillery Sidewinder. And I've got an inductive sensor on my artillery. Why can't I say it now?